Algebra 2, set 30, deductive reasoning, Euclid, vertical angles are equal, corresponding interior and exterior angles, and 180 degrees in a triangle. This lesson is kind of packed. So we'll go ahead and start with deductive reasoning. And with deductive reasoning, you have what are called arguments, and you have statements that are like this. We say, if A, then B. So, if something happens, then something else happens, basically. Now, the thing that you have to watch out for when you're doing deductive reasoning is if you have if A, then B, it does not mean if B, then A. So, for example, if a quadrilateral is a square, then it is a rectangle. Okay, so when we think about a square has 4 sides, has all 90-degree angles, and it has opposite sides are parallel, and I'm trying to think of what else. So the same thing is true for a rectangle, but a square has the special qualifications that all the sides are equal as well, which a rectangle does not have. But if it's a square, it is a rectangle. But going the other way, we cannot say that if something is a rectangle, then it is a square, because that would be false. So when we say if A, then B, that is what's called a major premise. And the arguments that you're going to see, you'll have a major premise, a minor premise, and a conclusion. These 3 things all put together are called syllogisms. So we'll just go through a few examples here of some syllogisms. All squares are rectangles. Quadrilateral ABCD is a square, and so quadrilateral ABCD is a rectangle. So the major premise is that all squares are rectangles. The minor premise is that you have quadrilateral ABCD that is a square. And you can conclude, since all squares are rectangles, that ABCD is a rectangle. Okay, let's look at another one. All poets are poor. Roger is poor. Therefore, Roger is a poet. Now, when we look at this one, it says that all poets are poor, and Roger is poor, so Roger has to be a poet, but this one is actually not valid, because Roger could be any other occupation and still be poor. It doesn't say anything about it. One thing that you can do when you're solving these is you can write it with the arrow and show that if somebody is a poet, then they are poor, but if somebody is poor, they are not a poet. Remember that it doesn't go, it's not, you can't switch the order. So if somebody is poor, doesn't necessarily mean they're a poet. Let's do another one. In this case, it says all chickens have 3 legs. Now, your first statement can be false, because we know that that's not true. All chickens don't have 3 legs, but we're going to assume that it's true for our case. And so when we say Henny is a chicken, all chickens have 3 legs. Henny is a chicken, therefore Henny has 3 legs. Now we know that in reality this is not true, but according to our syllogism that we have in front of us, it is valid, because if it's a chicken, it has 3 legs. Henny's a chicken, therefore Henny has 3 legs. Okay? If it rains, I will go to town. It did not rain, therefore I did not go to town. So this one you have to be careful with as well. This one is not valid either. It says, if it rains, I will go to town, and it did not rain. We don't have any qualifications for what happens if it did not rain. So I can't say what I did, because I don't know what I do when it doesn't rain, if that makes sense. Okay, so we're going to move on to another part of the lesson. We're going to talk about Euclid. Euclid was a Greek scholar, famous Greek scholar. He lived in Egypt around 300 BC. He compiled a compilation of books that are called the Elements. And basically what he did is he took the work of all of his predecessors and then he kind of amended it and added his expansions on everything. And that is a famous book now, or a famous set of works that was compiled by Euclid. And in Euclid's Elements, he came up with axioms, or what we call postulates, that are self-evident truths. So they're basically things that are true no matter what. So we have Euclid's postulates here. We've kind of narrowed them. They've been narrowed down to 10. We'll just go through them really quick. Postulate number 1 is saying that 2 points determine a unique straight line. Postulate number 2, a straight line extends indefinitely far in either direction. Postulate 3, a circle may be drawn with any given center and any given radius. Postulate 4, all right angles are equal. Postulate 5, given a line N and a point P not on that line, there exists in the plane of P and N and through P one and only one line M which does not meet the given line. So in other words, there's only one parallel line that can go through P that is parallel to N. Postulate number 6, things equal to the same thing are equal to each other. Postulate 7, if equals be added to equals, the sums are equal. Postulate 8, if equals are subtracted from equals, the remainders are equal. And postulate 9, figures which can be made to coincide are equal or congruent. And postulate 10, the whole is greater than any part. So those are the postulates. We're going to do a few examples using the postulates to prove a couple of things. So the first thing we're going to show is that vertical angles are equal. So if we have two lines that are crossing and we've labeled all of the angles, we know that x plus y is 180 degrees because they are on a straight line. And I can also say that x plus z equals 180 degrees. Since these two are equal to each other, or equal to 180 degrees, they are equal to each other using Euclid's postulate. So x plus y equals x plus z. I can subtract x from both sides and find that y is equal to z. And y and z again are vertical angles. Now I could do the same thing using the same procedure to prove that x is equal to p. Okay, just reviewing, if I have parallel lines and I have a line cutting through all the parallel lines, if it's perpendicular to one of the lines, it's perpendicular to all of the lines. If I have parallel lines and a line cutting across, it's called a transversal, and all of the small angles are equal and all of the large angles are equal. Okay, talking about what we call interior angles. So when we speak of interior angles, you're talking about two parallel lines and a transversal that's cutting across them, and the interior angles are the ones that I have labeled here. They are inside the parallel lines, and we've got a pair of small and a pair of large angles. Okay, if we're talking about exterior angles, exterior meaning outside, then we're going to go outside of the parallel lines, and you'll have a pair of small and a pair of large exterior angles. Corresponding angles, since the lines are parallel, the angles for each line are going to match each other. In other words, angle A matches angle A, angle B coincides with B, C with C, and D with D. And then finally, alternate interior angles. So interior meaning inside of the parallel lines, and then alternate meaning they're on opposite sides of the transversal, opposite sides of the line. So the small angles here are what we would consider alternate interior angles. We would also call the large angles alternate interior angles. So again, they're inside the parallel lines on opposite sides of the transversal. Now, vertical angles, through vertical angles, we can also say that those large angles are equal and those small angles are also equal. So we're going to show now that the angles in a triangle add up to be 180 degrees using the postulates. So the first thing we'll do is we'll extend all of the lines of the triangle. So you'll notice I've extended the lines of the triangle and then I've added a parallel line that is parallel to the base of the triangle, and the parallel line goes through the point that is angle B, the vertex of angle B. So we're going to look at these two parallel lines and we're going to look at the transversals. The first transversal is where A and B are, and we'll notice that we have alternate interior angles. You have a transversal cutting through those parallel lines, and then the blue is highlighting where the alternate interior angles are. We know that alternate interior angles are equal. And then you can also see another pair of alternate interior angles with another transversal, marking with the yellow highlighter. C is also equal to that angle up top. So we have A and C up where the blue and the yellow highlighter are. So notice that angle A and angle B and angle C are all along a straight line. So we know that A plus B plus C has to equal 180 degrees.